Good afternoon, everybody. It's 4 p.m., so it's time to start with our webinar. My name is Štěpán Čonka, and I will show you today how to convert the IFC model to valid analysis model and how to work with this model in SCIA Engineer. And we will touch a little also the revision handling of the analysis model and also of the structural model in an IFC format. Together here is with me Robin Blažek. Robin will be active on chat and in questions part, so he will be answering your questions during the webinar, but in case there will be a lot of them, we will answer them afterwards after webinar. So that's it, and I think we can start. So it's great to have you here, and let's get started with the webinar. So first of all, webinar is recorded, so there will be the recorded webinar will be then posted on the SCIA YouTube channel. For the questions, you can use the question box in the Go to Webinar tab, and you are all muted during the webinar. So that's some practical information about the webinar, and now we can start with the presentation. At first, I will show you a few slides about what I'm going to show you today, and then we will go to the practical examples, and that's it. So today I will be speaking about SCIA AutoConverter. SCIA AutoConverter is a web application which is designed for the conversion of IFC models to the valid structural analysis models that can be then calculated in SCIA Engineer, for example. So the purpose is to convert the model you see on your screen to something that looks like that. You can see that the volumetric model have changed to the model represented by the planes, the system planes and system lines, and this what we see now is the valid analysis model. The creation should be done in automated or semi-automated way, and that we will go through today. So it's all about the automation during the analysis model creation, and we are trying to get advantage of the IFC format that is quite often used, and it's great for data exchange. So we would like to get the best of it also for the structural engineers. Then the goal is, of course, to have a valid model in SCIA Engineer at loads, at supports, and do the design and checks of the whole structure. What else is SCIA AutoConverter capable of is the handling revisions. So we can have multiple revisions of the structural model in the IFC format. As time goes, the building is developing and everything is changing. So with the handling of revisions, we can always be on track what's new, and with the changes we can update our already existing analysis model. Also, I would like to show you how to do it in today's webinar. And the other way around, from time to time, there are some necessary changes in the structural model that needs to be communicated back to the guys that are working in Allplan, in Revit, in Archicad, and they need to adapt something based on the structural analysis needs. So we are also able to compare in SCIA AutoConverter the analysis model revision, and then we can create tasks for our colleagues that are working in the Archicad, Revit, or Allplan, or other softwares that are capable of importing the BCF format. So that's in general what I will show you today, and briefly about the BIM workflows that are available at the moment. On the screen, you can see the example of some kind of CDE platform. For example, we can take BIM Plus from Allplan, and the CDE Common Data Environment platforms are great for collaboration and offers a great features for the construction and design processes. On this CDE platform, there can be stored multiple models. As we can see here, we have some structural model, we have architecture model, we have MEP model, we can have also surroundings model, external pipings model, etc., etc. And these models we can put together and work with them. We can use this CDE platform for the clash detection, for the status management. We can assign the rights and roles to whoever is participating in the process. We can use it for the issue tracking and revision management of the models. And also we can store the information in one place, and these informations are, let's say, a bit better than simple PDF files. For example, we can add metadata to anything, and it's great for the corporation and whole construction process. But the structural analysis model stands a bit aside of all these advanced processes, and what is our vision is to connect what is structural engineering doing, the structural analysis model, also to these processes and integrate them inside. Because with the SCIA AutoConverter application, the structural analysis model is connected to the IFC model, to the structural one that could be stored on the CD platform, for example, the BIM Plus. So that's briefly what we are. Where we are trying to get, and now a bit more practical picture. So on the left hand side we have some BIM software. It's a BIM authoring software, so it's where the structure is modeled from the beginning. It can be Allplan, it can be Archicad, it can be Revit, it can be Tekla, and it can be a lot of others. What we need is capability to export the IFC to IFC, and then the model is uploaded to the SCIA AutoConverter, which is running on the top of BIM Plus from Allplan. That upload can be done via IFC file or via API call, which is available, for example, in Allplan. And in SCIA AutoConverter, then the conversion is done. And the conversion is done by structural engineer. And the conversion, I mean conversion from the structural model to the analysis one. Yeah, that's where SCIA AutoConverter is used. And then after that, we can take our analysis model and use the API calls or export to SAF. SAF is format for the data exchange of the structural analysis model, which is now quite widely adopted and used. And then we can import our analysis model into our structural analysis software that we can see on the right-hand side of the screen. In our case, we will use SCIA Engineer, the latest release 22, and that's it. These arrows are both-sided, so it means also, as I mentioned in the beginning, in case we are using SCIA Engineer, then we can upload then the revision of the analysis model, doing the comparison, create a task, and then we can inform about necessary changes our colleagues that are working in the BIM authoring software. So this workflow is working both ways. And that's it for the presentation, and now start with the practical part of the webinar. So let's get to it. I am now in my web browser. I have there the URL for SCIA AutoConverter. I will use my credentials for logging in. So I will just sign in. And now I am in the environment of SCIA AutoConverter, which is the web tool for the conversion of the models and handling the revisions. And what we can see here, at the top bar, I have a team in which I am working right now. It's called Allplan SCIA CZ. I have there my project, which is called Allplan Statica 2022. And also, I can change the language here, I can log out, or I can see some notification related to what's new in the latest release, for example, or with some important information that can be provided to me by the AutoConverter team. And on the left bar, we can see the basic workflows. The orange one is the one where we are now. It's related to model management. Then we have the S2A workflow and the revision compare workflows, mapping, reports, and SAF import export options. Today, we will be working in the S2A and in the revision compare path. So these three are the most crucial for us at the moment. And on the left tab, on left tab, we can see the models that are available there. There is several of them. Most important for us will be the first one. This is a structure model, and also we will work with this webinar AM. It's then derived from the first one. I will explain during the webinar. So let's start. I will start with the revision, the first revision of the structure model. I have there two revisions. It's because of that I want to show you also the handling of the revisions. We can briefly take a look how the model looks like. It's a kind of complex model with basically a lot of stuff, not only the load-bearing structure, but also a lot of elements around, also the surroundings, etc., pavements, lawns, and cars, and all of this stuff. So that's the model that we'll be working on. We will focus on the structure that is middle of the screen. And the goal now is to create from this model the structure analysis model, imported that model into SCIA Engineer and calculate it. That's our first task. So let's get to it. For that, I will use the workflow that is called convert structure model to analysis model. I have still my model active in the screen. If I want to do it, change the transparency or the visibility, I can do it in here in the models part. And now we have model selected. When model is selected, it means it's visible in the scene. What I can do here, I can expand the model and I can check out the available disciplines. I can see that there are a lot of them. There is a building, door, window, general object, finish, and room, etc. Some of them are not related to our domain at all. So for example, I know that I can disable room discipline, finish discipline, and door and windows discipline. Yeah, so I can see either the number of objects in the scene have been reduced, but I didn't remove anything related to the load-bearing elements of the structure. So now I've a bit reduced the number of elements that I have in the scene, and I will go to the next step. Model was selected. Now we are in the clean step. Clean step is dedicated to cleaning the structure, and it means that after the clean step we would like to have in scene only the load-bearing elements. How to do it? How to remove all the elements that are not load-bearing or we don't want to have them in our analysis model? There are a few options how to do it. We can use the IFC types, the predefined IFC groups that are available on the left tab. IFC types will help us to define a big group of elements. What is red, it means it's selected in the scene. So for example, the geometry object IFC group has 620 of elements inside. So in case there would be something that I can remove as a bunch, as a whole group, then I can do it on the left hand side. But in this case, I need to filter out manually, more or less. And how to do it? I can do the selection in the scene. So I can simply click on an object and then hit the remove icon, and the object will be removed. I can also hold Control and then select multiple elements at once and then remove them. I can also use the area selection. So it means I can simply select these trees and remove them out of the scene. And another option that I have is using the common attribute of more elements in the scene. So for example, I can select this lawn, and I can select material equals lawn, and I then click on it. And every object that has material equal to lawn is now automatically selected. So I have selected 13 elements based on this property, and I can remove them. Obviously, can happen that I will remove something that I actually want to keep. So for that case, I can switch between active and not active filter. So now I am seeing the elements that I removed, and I can simply select the element that I want to have back and put it back. So based on these procedures, I should be able to filter out only to load-bearing structure. When I am satisfied with the state of the filtering, I can save my filter and give it a name, then click OK, and filter is saved, and then the filters are always available for me when I come back. So I can use, or I can give it a name, webinar 01, for example, and save it. And every time I will log out, turn off my computer, and I will go back to that structure, then I can recall the filter webinar 01. I will use that function, and I will recall one of my previously prepared filters. So now I recalled a filter when only the load-bearing structure is kept in here, and with this state I am satisfied, so we can proceed to another step. And maybe before we do it, I just want to mention a building structure. That's something that is usually available in the IFC exports. It's not all the time the case. It depends on how the IFC is created and what translator is used and how you have set it in the BIM authoring software, but might be useful. It's usually created based on stories. So for example, I can disable the roof and the fourth floor, and it's usable, or yeah, it's very useful for the filtering, because I can then take a look from top inside the building, and I can check out if all the non-load-bearing elements were really removed. So that's something that also might be quite useful during the filtering step. But now the structure is very nicely filtered, so let's proceed to the next step. The next step is called recognizer settings. It's the third one from the 6 in total. So this our structural analysis model should be created in the 6th step. Now we are almost halfway done. Recognizer settings. What the recognizer settings is about? Recognizer settings basically is telling the algorithm how it should handle one and each element. It means how, on which type of element it should be converted, and what attributes related to cross-section, materials, and layers should be assigned to these elements. So let's start. We are first in members. So in members, we are defining what should happen to the elements during conversion and how they should be handled. We can see there are predefined groups: column, wall, slab, and beam. These groups are predefined based on the IFC type. So the AutoConverter is not helping us with these definitions, but in case we are not satisfied, we can select an element, we can move it to another group. So I have created a new group where only this beam is present, and I can say, okay, I want to have this beam recognized as 2D, and I want to be 2D type wall. So then the preference is to recognize it in vertical way. And I will just briefly jump to the next step, only to show you what does it mean. I've said it should be a wall, and now the 2D element was created from it. I will now delete it and go a step back, and I will change recognize as to 1D, and I will set the type to beam. And again, I will just recognize this only beam, and now see that from that 3D object created based on IFC is now a beam represented by the system line and the cross section, etc. So that's something that I can, let's say, set for the autoconverter, how to handle these elements. I will now remove or put this element back to the groups of beams, and I will delete the group I have created right now. Also, what I can do is, for example, that I can say, okay, let's recognize this element as a solid. Solid is something like a 3D representation. It's it's not an analytical element, but it's useful mainly for some complex geometry, double curved slabs that we can't handle. Then it's useful to recognize them as a solid, because at least I can use these solids as snapping points inside the SCIA Engineer, so I won't lose the geometry. Maybe I can, if I'm talking about, when I'm talking about it, I can show you what the solid is. So again, I have the beam in selection. So I will create a group once more. Oh, it's this one. Cool. And I will recognize, and we will see that it will become a solid. So it's this one. Solid might be a beam, and recognize. And we see it's a 3D object, and these vertices will be used in SCIA as the snapping points afterwards. So again, go back. I will create a group beams again, and I want to have them as 1D. So it was about the member groups. Then we can go to the next step, to the cross sections. I will put it into a default state. I know that in my structure I have 3 steel elements that have manufactured rolled cross section. So I can find the property, is the section name. And in this case, the goal is to map these section names equals to HEA 500 to SCIA Engineer profile library. So after import of my analysis model into a SCIA Engineer will handle them as manufactured rolled cross section, not the general ones. Yeah, so it's a useful. It's very useful. So how to do it? I know it's the profile is stored under property section name, so I will add the section name as a property used for the mapping. Now here in the CSS mapping part, I can see that IPE 500 was already mapped because the property name is 100% equal to the property in the library. In this case, there is a space, so it was not automatically mapped, so I need to do it manually. So I will open a mapping dialog. I will go to manufactured rolled cross section, I section, then I will find HEA profile, and I want to have HEA 500, and the profile is mapped. The rest of 1D elements will be recognized as general. If possible, then they will be recognized as parametric rectangle or parametric circle. Also, in case I would work with the steel structures, then I might be useful to use the mapping via Excel, but in this case, it was very easy to map them manually. Then we can go to the materials. Materials, as is obvious, is about assigning the correct materials to the elements in the scene. It works very similar to cross-section. We need to find a property, and then we need to assign a correct material. So I have the concrete part and the steel part of the building. And the same way, we can handle the layers as well. In case some IFCs can have stored in one of the attributes data about layer, so we can then reuse this data and predefine the layers already in the autoconverter. But in this case, I will leave it. What I want to mention is all around the AutoConverter, in all workflows, in all parts, there are these small eye icons. These eye icons are tooltips. Then they will guide you through the whole process. So in case you are not sure what you're supposed to do in every step, you can open a tooltip, take a look what's supposed to be done. And if there is a tutorial video available, then there is a link to the tutorial video. So it will guide you through the process safely. Now we are done with the recognizer settings, so we can go to the step which is called recognize. So I will just recognize the structure, and before the recognizing actual structure, there is something called recognizer settings. It means we can predefine some rules for the recognizer, how it works. For example, enable or disable parallel member detection. It's about recognizing two elements close to each other as compound section or general compound sections. We can set a minimal 1D size, useful, for example, if you have a steel structure where there are a lot of balls in the connections and they are not easily to be filtered out in clean step, then we can set some minimum size, and all which is not satisfying this condition will be placed in a special group, and then we can get rid of them at once after the recognition. So this is some rules how the recognizer is working. Again, for everyone, every rule is there a tooltip. So, but usually it's quite good with the default. So let's do it with the default. And that's it. Recognizer successfully ended. What we can see right now in the scene, we have transparent our structural model, and inside that model is another one. It's called recognized. Recognized model is already an analysis model. If we take a look on the properties, we can see that slab has name S100. There are some eccentricities that are equals to 0, but it's defined by nodes. It's flat and had thickness of 250 millimeters and has some material C37, the concrete. So now we have already an analysis object that SCIA Engineer will understand properly. What is not perfect or needs to be adjusted is the fact that the recognizer is only recognizing the elements. So they are touching at the faces, and we can see that the center lines are not connected to each other. So this model is not valid for the calculation because these connections are not yet created. So that's why there is the next step called alignment, and let's go to the alignment. So the purpose of alignment is now connect these elements that we have recognized, and how to do it. Again, we have there some alignment settings, which is quite similar to the recognizer settings. At first, we have there the system lines, and in the system lines, we can again move the objects around the groups, and we can play around with the system lines. So we can adjust the position of the system line. So we can say, okay, this slab should have the system line on top, or this wall should have system line on bottom. The system line positions are related to the LCS positioning. So it means top is positive Z axis. And what we can also set in here is the eccentricities, because during alignment, elements are moved a little. They are extended, of course, but they can be moved as well. And with that eccentricity setting, we can say if we want to store that move as an analysis eccentricity, which is then taken into account during the calculation and analysis. I will keep them all none. It means I don't want to calculate with these eccentricities in my analysis. Another tab is element behavior. Element behavior is at the beginning empty. There is nothing. Element behavior is affecting the result of alignment the way that it prevents specified elements from the movement out of plane for the 2D, and the center line movement along X and Y, along Y and Z axis, obviously for the 1D. So we can say, okay, algorithm alignment, these elements are not supposed to be moved at all. You can see I have there some elements already predefined in the groups. For example, these walls I have put inside one group that is not supposed to move during the alignment out of its plane, and it's because I want to make sure that this gap between the wall and this element on the outside will be separate, yeah, because there is a structural gap in the model, so I want to keep them separate. So that's why I did it. And that's basically it. I think we are ready for the alignment. So let's go to the next step, which is actual alignment. So there is an align button. Align button will run the algorithm and it will connect my elements together. Before the alignment will be run, I just want to open for a second the alignment settings. There are two parts: general alignment settings and alignment connection settings. General alignment settings is related to actual extension, node movements, etc. Alignment connection settings is more or less about generation some additional objects. So it means we can create RIPs, we can create subregions, we can generate intersection, and we can generate internal nodes. RIPs, intersections, and internal nodes can be created in SCIA Engineer as well before calculation. So it's up to you if you want to use these features already in AutoConverter or use them afterwards in SCIA Engineer. And now, more importantly, to the alignment settings. There is a maximal node movement. That's kind of a general high or the top limit of the total movement that node can be moved during the alignment. Again, there is a tooltip, so we can see that the maximum movement is that total movement available. We can always change these values, yeah, via with these arrows, or we can just type in a new value that we want to use. Then there is the extension of 1D elements. That extension could be automatic or set by a hard set value. We can generate rigid links, and we can say every connection longer than 20 centimeters should be done via rigid links. Also, we can define some rules for the master planes. For example, intelligent search for search for shared plane in case of steel halls with the inclined roofs, and we can do a lot more. Set the maximal transition gap distance between elements, or set angles that are mainly useful in case the structure or the IFC export is a bit inaccurate, so we can help the alignment to have a better result with providing some low angle value. But that's it, and let's run the alignment. At first the simple one, then I will show you alignment per groups, what can be done with that, and let's check out the result. So now we can see that at the first look the structure looks quite well. Again, we can, for example, turn both models on and inspect the structure like this, or we can again turn the transparent model, the structural one, and then expect a structure like this. We can focus on this detail that I showed you in the recognizer model. Now we can see that the columns were extended to the slab, and we can see that all the elements seems to be connected properly. Also, we can see that from this beam there was a created rip because I had the toggle turned on, and that's it. That's it for the analysis model creation. Yeah, and about the alignment, there is one function a bit more advanced for the alignment, but I want to show it to you as well. It's called alignment per groups. I will turn that toggle on, then the grouping is offered here for me, and I have prepared free groups. What does it mean that alignment pair groups and my free groups? Basically, I can regroup all the elements as I wish. I can create new groups, I can switch the groups between each other, etc. Then I can reorganize all the elements as I want. The main advantage of the alignment pair groups is that every group has its own settings. So I can change the settings for every group, and thanks to that, I can get a even better result from the alignment. Usually what I do is that I'm ordering the groups with the maximal node movement. So first group is the biggest elements where I want the biggest move, and then I am reducing the move of every other object. Yeah, so if in case I will run these alignment per groups, then it means that the groups are being aligned one by one. Group A, then together group B, and then together to AB group C. So yeah, and this is the result. So now we have an analysis model. And now how to get this model into our structure analysis software. I will check briefly at time. I'm talking too much maybe, but okay, let's continue. Okay, how to get this model into SCIA Engineer? We have there 3 models available. We have structural, that one is based on IFC. We have then recognized model, already analysis model, but not connected, members are not connected. And then we have the aligned model. That's the model that we are interested in. And to save it or export it, we need to click on that cloud icon. We have 2 options for export. We can either save it on BIM Plus, so it means it will be saved on cloud inside the SCIA AutoConverter and Alpan BIM Plus, or we can export it into a SAF. SAF is that XLS file that can be then imported into SCIA Engineer manually. In case you are users of the AutoConverter, then it's better to use the BIM Plus option, because then you are not losing the connection between the actual IFC file and structural model and the analysis model. So it's used then in the working with revision and with the round tripping. So I will create a new model. So create new model, and I will just give it the name example. Now the model is being saved on BIM Plus. It takes a few seconds, hopefully. And now I can delete all this and go back to Model Manager or View Models. And now we see that there is an example being processed on the server. And when it's available, then I can use it. So now it's available. Okay, so we have created an analysis model. I will show you one more little trick. It's related to that AutoConverter is running with synergy with Allplan BIM Plus. So with the AutoConverter license, you have you can automatically also log into Allplan BIM Plus. It's connected. So what's interesting, now I'm in a BIM Plus viewer, the viewer that is used for the CDE from Allplan BIM Plus. And on the left-hand side, I have said there's some model selection. And what models I have selected? I have our structural model, and also I have our analysis model that we have created. And I've used the trimming option for the 3D scene. And I can simply cut. Yeah, I need to go more down, cut through the building, and it's quite useful for the check of the analysis model, because now I can see all my analysis elements, center lines that are placed in the right positions. Yeah, so that's a nice feature that is available in Alpan BIM Plus that I can use as well for the checking of my structure. Yeah, so I can see also the center lines of the beams in here, the center planes of the walls. And if I want to be sure that everything is in place, then I can use this feature. So that's briefly to BIM Plus Viewer, and now I will go into the SCIA Engineer. I have there pre-opened some models that are basically related to the stuff with the revisions, but now I want to get that model that we have stored on BIM Plus to get it into SCIA Engineer. So I will go to File. I want to open from, and we save it on a BIM Plus. So I will use same BIM Plus option. In case we would have the SAF model, then I would use the SAF model option. So I will open it from BIM Plus. Then the BIM Plus dialog should start, and the BIM Plus dialog should ask me for the credentials. And these credentials are the same as for BIM Plus, as for the AutoConverter, and for this dialog as well, because all the data are stored in the same place. So I don't need hundreds of logins and passwords. I have one for my AutoConverter and BIM Plus. Now I am logged in, and I need to select the right team, right project, right model, and the right revision that I want to open inside SCIA Engineer. So I will find the right team. I will find the right project. I will set the right model. I will open the example that we have just created together. We have only one revision, and I will hit the download button. Now SCIA is fetching the data from the server. It's opening a new project and filling with the data that we have just created in the SCIA AutoConverter. This is the SAF exchange dialog. Usually I can remap the cross sections, but it's not needed. In case there are some errors, for example, during the SAF import, which is not usual case for the BIM Plus import, that I can use the info. For the in the info under the info button, there is always some information about the model validation. So that might be useful for you in the future. And then I will just click OK. Okay, concrete member data. And we are there. So we have the model in here, and then we can work on it. Can add load cases, add boundaries, add loads, etc., and work on the model we have just created. I will now skip to the model that is called imparted for calculation. It's the same model basically that we have created. Only thing is that I've prepared 3 load cases with the surface loads applied on the elements, so I can visualize this load data. So for the load case 3 and load case 4, or load case 2, I have the surface loads on the surfaces, and I've just calculated the structure. So this structure has available results. We can maybe briefly check these results, and type selection all. Okay. So yeah, we can check out the deformations, and we can see that this cantilever part of the building is affected by some high deflection, so some work of the structural engineer is necessary in that case, and that some work is necessary. So what we have did is what we have done is that we have now calculable model inside the SCIA Engineer. So then we would save it to SCIA file, and after our work is done, so it means we added boundaries, we added loads, we can then also export it back to the BIM Plus. How to export the model back to BIM Plus? It's easily done with the export to option. I will find the BIM Plus option. In the SCIA file, there are stored data about to which team, which project, and which model belongs. And then I can simply write down a revision name, revision description. I can choose if I want to export loads and export results. I recommend to export loads only. Results are I don't. Okay, it's up to you, but I'm usually exporting only the loads because there is no other party yet that would fetch the results from the BIM Plus, so I am not exporting them usually. And then you simply hit update button, and that's it. I won't do it because I did it in advance because I have prepared the model webinar, and the model that I would upload right now is the revision 2. Yeah, it's edit loads, edit supports, and I did some small adjustments in the structure. And so it's basically this model. And now we are in the situation that we receive another revision of the IFC file from our colleague that is working in the BIM authoring software. Yeah, so we have this, we have calculable model, and we receive another revision of the structure model. I received this one from my colleague Oliver, so I have uploaded a revision via AutoConverter either or via BIM Plus. In case we all in our workflows are working on BIM Plus, then most likely there will be created an issue on BIM Plus that will be assigned to me, and I can check out what actually was changed on the model already on BIM Plus. In case I am only working let's say alone in this, so then I can use upload revision in here. So let's start. What we want to do is to compare these two models that we have from Oliver and see the changes, and with the selected changes then update our already existing model. Yeah, that's what we would like to do right now. So for that, I will use another workflow, which is called update existing analysis model from structural. And it's quite straightforward. I need to select the structural model that we received with the second revision. And I will apply a filter that we have created in our S2A workflow. So it means I will remove all the cars and etc. And I will keep only the structure or structure model relevant for structure analysis. We can see briefly that there is clearly something changed. There is a new opening here. These columns have different cross section. They used to be circles as well, but now it has changed. So, but let's use the comparison. And now we are comparing the latest revision, the revision number 2, with the previous revision that we used in the S2A workflow. And I will hit the compare button. And now we can see immediately the result of the comparison. We have there different, on the left tab is the result presented. We have 0 modified properties, we have 2 deleted objects, and we have 5 modified objects. I will focus on the modified objects only because these deleted are actually not relevant for the structure engineering. They are related to some fillings of the openings. So it's some kind of different door type used. So it's not relevant for me. And I will focus only on that modified objects. So let's get through it. We have there 1, 2, 3 columns with a change cross section. We have there one wall where is a new opening for the door, and we have there the slab. How to check out what's changed? We can, like more specifically, we can check it out in the table overview when we will see also the property values like it was and are now, or we can use that issues on a BIM plus that I have mentioned previous few seconds or few minutes ago. So, but that's the other changes that were made to the model, and in here we can select which changes we want to apply on our already existing model. We can apply all when nothing is selected, or we can apply the sub-selection if we select them one by one. So I will do the selection. I want to apply these 5 changes to our analysis model, and I will select the model that we have used. I will select this one, and it's that we uploaded. And I will select the correct revision. Yeah, I want to update revision number 2. And let's wait till model is loaded. Now in the behind, you can see that there is already analysis model rendered. So we can see there is no slab, there is no opening for door, etc. So yeah, use selection and update the model. Yeah. So now we are in the recognize settings again. So the rest of steps is quite similar to the S2A. Yeah. So in case there will be a new cross section, then I need to remap it. In case there would be a new material, then I need to remap it, etc. But basically, how does it works? We take an already aligned model as a recognized, and the change and new elements we then recognize again. So you can see that now we are recognizing on the top of the bottom right, we are recognizing 5 elements. So it means these changed elements we are recognizing again, and then we will update with them our already existing model. So the recognition is done. We have 8 minutes to go. So, okay, now we can see that if I select the center line of that column, that the cross section has changed to parametric 750 by 400, and we can see there is a new opening in a slab, and we can see that there is also a new opening in a wall. So these elements were recognized correctly. We can go to the next step. Again, system lines and element behavior. We already set them properly in a S2A workflow, so I can go to the next step. And in this case, I don't need to use the alignment per groups. I can use the ordinary alignment to just align to the rest these 5 elements. So let's do it. And yeah, that's it. Again, we have the aligned model here. Benefit of this workflow is that we won't lose the additional data. Yeah, we can see that this slab was updated, but we didn't lose the load applied to the slab. Yeah, so that's the great thing about this update workflow. And again, after that, we can save our model. In this case, we would save it as a revision of the model. I already did it, so I won't be doing it now, but that's how the correct workflow would look like. And when update is done, then I will go back again to the view models, and I will just activate that third revision that we have just created with the update. So it means first revision was created in S2A, second was created after the calculation or making the model calculable in SCIA Engineer with adding loads and boundaries, and third revision was created with the update workflow. And now we can see again that's opening, and change cross section. Yeah, so basically that's about the update. Then again, we can just open again the project inside the SCIA Engineer and continue in our work. Yeah, so that's basically the other tab that we have open at the top. I need to close the dialog, and now SCIA Engineer should be available. So that third revision is here. We can see opening, change cross sections, and new opening in the wall. And what we can do after that, then maybe we can try to help that cantilever part to reduce the deflections. So I have there the last model, that's this one. And in this model, I have added something and changed something. Yeah. So I have added this wall inside the cantilever part. I have changed cross section of this column. I have added 2 extra columns in the cantilever part. So it's this one and also 1 column on the other side, this one. And I have deleted 1 column from this area of the building. And then I have uploaded back on a BIM Plus, and it's basically this fourth revision. Yeah, new wall, new columns, change cross section, change thickness, deleted column. Yeah, so that's that model. You can see there is a wall, there are new columns, etc. And the last workflow, very briefly, time is running, so I will just jump to that, is about the comparing of the analysis models and letting our colleagues know what have changed and what needs to be done. Also, I can use this workflow as a reminder for me how the analysis model was evolving, what has changed in which revision, and how the timeline is actually looking in the analysis model evolution. I will use that webinar analysis model. Now I'm comparing fourth and third revision, and I will just hit compared for update button in this case. So it means every analysis element is being compared. Now in the scene, I have the result. So everything that's changed, new or deleted is in the scene. I can toggle the transparency of the analysis model, so I am better informed about the location, and now we can see here the result. Yeah, so as I mentioned, new wall, 2 new columns, deleted column from opposite side, and also I changed thickness that I forget to mention, and there is that changed cross section for this column. From that, I can create tasks with that dialog, and these tasks are then communicated to the BIM Plus. And on BIM Plus, these tasks are available in here. I will disable that function. They are visible under the tasks, and I have created a task for the thickness of the slab. So this is actually how can I communicate it back. Also, I can adjust the view, like this. Also, I want to see the general elements. I can play around with the view, how to communicate it, etc. There's a lot of possibilities. I can take snapshots, but we can see that the change of thickness is clearly related to this part of the building. And then I can, for example, export it to BCF file, which is most of the softwares understand BCF files, or I can export the issue into XLS file, for example, if I want to share that XLS file with someone. Yeah, so this is the way how I can get now to my colleague working in Allplan, in BIM, in Revit, etc. What was basically changed. And that's all for today. Sorry for fulfilling the time 100%. I would like to thank you for your attention. You can follow us on LinkedIn or on my personal LinkedIn as well. Don't hesitate to contact us related to whatever question you have about the autoconverter. And I hope you like the webinar, and see you next time. I hope I will check the questions maybe if there is something. I can't see. I think. Yeah, I see that Robin was active. So that's great. Yeah, thank you very much for your attention. That's it for today. I hope you enjoy it and you will benefit from this webinar in the future. And yeah, thank you very much and have a nice day. See you next time.